Getting started a little early to see if it all starts up okay. It's been a minute since I've done this. Forgot to check my teeth. They're still there. Good preview. All right. We're getting 1080p coming in. Hi, Beata. If you want to join the Discord, you can go to the URL adafru.it/discord. We're in the live broadcast channel. That's what's over here in the middle. The bottom chat is YouTube. Hello, David. I started early because I didn't know if it was going to work. I haven't deep dived in like 6 months, so I'm going to hang out for a few minutes since it did work. It's a good problem to have, that everything worked, instead of being in the mode of like, I'm missing my time, which I've also done. So I'll say hi to folks, and if everybody wants to say hi, let me know. Otherwise, we'll get going in about 4 minutes, because it's supposed to start at 2 o'clock, but I haven't done this in a while, so I thought I'd give myself a little bit of a head start. But we'll wait and see how many people we get and stuff. How's everybody's Friday going? Sorry, when I look like this is the camera and chats are over here. I have gotten very nerd sniped the last couple, yesterday and today, which I'll mention. I'll mention even though it's not what I said we'd talk about today. Restream says it was deep dive with Tim, but I don't think I did update it. No, it still says deep dive with Tim. Does it say deep dive with Tim on Twitch or something? That looks like it's okay. I think it's fine. Everything going good on folks on the other end of the tubes? Can you hear me okay? Can you see me okay? Yeah, let me do my motion thing. DCD asks, any Zephyr targeting the Fruit Jam? We probably won't release it on the Fruit Jam, but you can usually build Zephyr for other boards as long as they have a Zephyr board definition, which I don't think they have a Fruit Jam one, but I'm not sure. So probably not. There's not a lot of reason to, because like Zephyr can't do the DVI stuff. And it can't actually do, one reason I would be interested in it is being able to do cross-core stuff, but I think nobody's taken that over the finish line for Cortex-M. So you can't actually do symmetric multiprocessing with Zephyr on Cortex-Ms yet. So, you can hear my notifications. Let me switch those to my headphones, so you don't think you're getting a Slack message. All right, I'm gonna get started in just a moment. I'm glad you're doing good, Beata. Decently good. All right. It worked. I'm just watching my clock. We'll start at 2. See if we get any more people. All right, it's 2 o'clock. We've been hanging out for 5 minutes already, so let's get going. Hello, everybody. My name is Scott. I go by TanNewt online, and this is Deep Dive. I started deep diving a number of years ago, where it was just a chance for us to hang out, show what I'm working on, and folks ask me questions. I work for Adafruit. They do open source hardware and software, and I'm on the software side of that open sourceness. And I work on CircuitPython, which is a version of Python designed for little tiny computers called microcontrollers. And this is the moment where I look at my desk and I say, what do I have here? Let me grab this. So here's an example of a microcontroller. It's under this metal can here. And this is one of the things I got nerd sniped by. So I had this concept of being nerd sniped, which means that I get interrupted and disrupted into working on something I didn't think I would. So this is an ESP32 here on this board, and it comes out of this. This is part of the inside of it, but it's part of this kid's music player. And I've been poking at it to see if we can get CircuitPython running on it, but getting all of the other stuff supported, so that we can just use those as CircuitPython devices. So I got distracted by that. Yeah, so this is Deep Dive. If folks have questions, feel free to drop them in the chat. I've got the Discord and the YouTube chats up, but I also am watching a few of the others like Twitch through the restream thing. So the stream is available not only on YouTube, but a couple other places as well. Yeah, this is my first time back. I took about 6 months off of Deep Dive because I was watching my youngest, who was born just over a year ago, watching her as my partner went back to work. And so I was working 2 hours a day, and that 2 hours was not Deep Dive. That was mostly email. But my youngest went to daycare in December, and so she's settled and happy, so I'm back full time working on CircuitPython. And starting in the new year, I wanted to get back to doing deep dives as well. So that's it. Adafruit.com if you want to purchase stuff. So I said hi to the few folks who dropped in the chat, so thank you to those folks. Oh, one other housekeeping thing is I think my plan is to only do an hour. I used to do 2 hours, but I think we're going to shoot for an hour, and if we happen to go over, that's fine. Rather than doing a 2-hour marathon like I used to. So my plan today, hello to Shipu from the tropical Switzerland. Is it nice and warm and rainy there? That's how Seattle's been mostly too. So I really wanted to talk about CircuitPython 2025 in preparation for talking about CircuitPython 2026 next week. There is a chance I may not stream next week because we do have some friends in town and I'm not sure what their schedule is. But I'm going to try to do it. So let's dive into that. And then if folks have questions, we can go on tangents and stuff too, like the good old days. So every year, well, I should say happy birthday, CircuitPython. So we released the first CircuitPython beta in January 9th of 2017, so 9 years ago. And that was the moment that we switched early on. I started development the previous August or so, working on MicroPython. I think we did a few releases as Adafruit MicroPython, but we found that we were very worried that was going to be confusing, especially if we weren't going to merge upstream kind of quickly. And so we, January 9th, 2017, 9 years ago today, is when we announced that it was going to be called CircuitPython instead. And I think that was the right call. It's much clearer about what you're talking about with that. So happy birthday, CircuitPython. For a number of years, we've been doing kind of CircuitPython end of the year, this kind of annual, like, let's talk about what we want to do in the coming year. And it's like doubly important for me because I've been full-time for about a month after being off for 6 months or so, or at least part-time, not getting a lot done for 6 months, more being a support role. So now's a really good time for me to me and everybody else to reflect on kind of what our priorities are for the coming year, especially because, and we'll look at mine from last year, but I knew I was going to take a bunch of time off last year, and so I can be more ambitious in my personal work going forwards as well, because I don't have any. I'm sure I'll take some time off, but not like months and months like I did last year. So again, if folks have questions, let me know. Otherwise, let's go to the desktop and we'll take a look at. So this is the thing. One of the things I've been hacking. This little kids audio player, and I've got one torn up on my desk, and I think I realized that the display here is driven through an I/O expander, which is unfortunate. So I kind of got to let my brain chew on that. But, okay, so let's talk. We've been doing this annual planning. We have a blog post here, and we can see 2019, 2020, 21. So let's see, 1, 2, 3, 4, 5, 6, 7 years. So this is our 8th year in doing it. Hi, Hams Labs. Nice to see you too. It's nice to be back. And I should say thank you to Foamy Guy, aka Tim, for filling in for me. Keeping the chair warm for deep dives, and I'm sure I think Tim, if I ever do have to miss a week, he'll be happy to join in. And if you do miss Tim, he usually streams Saturday mornings on his own channel as well. So let me just get back to my thought and post the link there to the CircuitPython 2026 kickoff. So if, as you're talking about this, you want to kind of join in and let us know what your thoughts are for the coming year for CircuitPython, that's a way to do it. And let's go here. All right. So the way that I kind of like to do it is I like to do kind of a read over the previous year to see how well we tracked on what we were going to do. And also, just kind of reflect on how the year went. And then next week, I'll plan on writing my CircuitPython 2026 and talking about that on the stream. Whatever the next stream is, either next week or the week after. Okay, so I was looking this briefly. So one of the, actually, let's just go through these, just to queue them all up. I'm not going to watch the video. Okay. Oh, I didn't even get through email today. Hi, Jono. Happy New Year. Thanks for stopping by. So the big news on Jeff's front was that Jeff was going to stop working on CircuitPython on a regular basis. And he announced that this time last year, which did come to fruition. So Jeff has gone off and done what his heart desires on the timeline he does. So again, congrats to Jeff. Happy to have him back whenever he wants to hack on something for CircuitPython. Let's see, this is for Foamy Guy. So what did Foamy Guy say last year? Intrigued by Zephyr. Interested at LVGL, which are two things. I've done some more Zephyr work. I have not done LVGL. Crypto stuff for CircuitMatter we also haven't done, and we plan on doing. Yep, and now Tim is working on Adafruit stuff and CircuitPython full time, which is awesome. And he's been doing a lot of driver libraries. No Meshtastic stuff either. Games for CircuitPython in 2025. Yes, Tim did a lot of stuff around the Fruit Jam last year, which has been, and led the effort on Fruit Jam OS and stuff. So that's been really cool to see. So yeah, some stuff we haven't done, some stuff we did do. Let's see, what did Cooper say last year? Interested in the migration over to Zephyr, maybe multi-core. We don't have multi-core, and Zephyr's been progressing, but it's still quite a ways away. Still on the agenda. Anecdata said low-level async for sockets, which they actually already posted their CircuitPython 2026, and it's just this first one. Updated memory pool APIs, which we did not do. API to expose pre-safe mode execution info. I think that was added. And Ethernet over USB we haven't added, but somebody's brought up again recently, which is kind of weird and interesting. I'm starting to understand it, but you can have the device you plug in over USB act like another network and load it up in a web browser, which is kind of weird. Hardware wish list, Metro and Feather with ARM2 Wi-Fi, which we don't have. Tiny TFT BFF we don't have, and the different size feather wing we don't have either. So still lots to do, which is great. Oh, Paul's blog posts moved around. Let's see. I don't know. I know that Paul announced the return of the CircuitPython show, which I think has still been happening, which is cool. Some Nice, aka Andrew last year, a library for working with vectors. Which we haven't done either. There's still so much we can do. Sam Blenny talks about building blocks for devices that can, standalone devices that can play games. Getting gamepad input working. Bluetooth gamepads. Bluetooth gamepads we don't support, but there has been a ton of work on input stuff for the Fruit Jam. Cards. Dozens of cartridges. It's interesting because these this Yotto thing uses NFCs, so it doesn't, the NFC cards don't actually store anything. You use that to select what you want to listen to, which is an interesting interfacey sort of thing. I think Anne thread for CircuitPython 2025, floppy support and classic computer emulation. We didn't do the floppy stuff, but classic computer emulation definitely did quite well for the Fruit Jam, and Anne definitely worked on that a lot. Zephyr would allow new microfamilies to be easier. P4 and 2350 bring a lot of power. Or video resolutions. The new port to Zephyr will allow multiple cores. Still not there yet. ESP32P4 support is not in Zephyr yet, so that's part of it. And they don't do multi-core for the RP2350 yet. Yeah, my brain's just, it's good getting my brain into it, although it's also Friday. Okay, so what did Dan talk about? Better async IO support. This is still something I would like to do. I would like to better integrate async IO into the core APIs, especially like Ryback is looking at, I think it's Ryback, looking at like they want to do display calculation at the same time as doing the transmission of the display pixels, and we would need like a lower level async thing there. Automated hardware regression testing. This has come up in my brain again. We didn't do a lot last year with it because we just like we didn't have that many people working on CircuitPython full time. But hardware regression testing is really interesting in the context of more LLM generated code. If you use LLMs to generate code, you need to be better about testing it. You should be better if you write it anyway, but like you can know correctness through testing as well. Code editing for beginners, sunsetting of Mu. We haven't handled this yet either. Mu is still available so people can use it, but it's not being updated at all. So that's kind of on the radar too. I still think code.circuitpython.org, like Melissa's still doing work there. Auto mounting SD cards we do. Only on a few things in FruitJam, and we make them available over USB. So that's something we did do over last year. 3 more posts. CVA Schmidt posted about the DIS module. CircuitPython powered Home Assistant plugin. Retired Wizard. I know Retired Wizard did a lot of FruitJam related things. WLED is interesting. I think WLED and like Pixel Blaze are some of the more innovative things within the realm of CircuitPython and hobby electronics. I just don't see a lot of that happening from like Arduino, for example. Although I did get some of those modulinos, and I want to poke at those at some point too. Home Assistant. I've not done Home Assistant, but I think we want to get into this. We want to get back to CircuitMatter because we spent a lot of time on it, and we never got it to the point where we could run it on CircuitPython. So that's definitely something we want to revisit this year, so that we can do CircuitPython integration with like Apple Home and Google Home. All right. Oh, I did open it. I opened that twice. And CVA Schmidt said, I'd like to be able to do the disassembler, which we definitely don't do. I think that's a very niche thing. Thani, I always like Thani better than Mu. Maybe Adafruit can help keep it alive. I think Thani is still alive and well. It would be nice if Adafruit documentation sources had more cross-referencing. I wonder how CVA Schmidt would feel about this now, given like that a lot of people use LLMs to answer questions, I think. Okay, I'm going to skip mine for just a little bit. Arun says, support for CircUp over USB serial, which I believe we do have now. It doesn't work like MP Remote, but it does work. CircUp does. And then Zigbee support on the C6 we do not have. I think we're more likely to do Thread first. But then again, Zephyr, I think Zephyr does have Zigbee support. Basically, if I'm adding new support for things, I'm like, does Zephyr have it? And if it does, like, let's do that. If I do it through Zephyr, then it's like kind of the only thing that we need to target. I don't think it does. that's not a very useful answer. Yeah, it seems like Zephyr doesn't have Zigbee. Maybe it does. So Zephyr doesn't have it, but like the derivatives do. Well, let's see. Mark said, late to the game. Happy I looked into audio effects. I noticed those were there. I had just turned them on for the Zephyr port in my branch, not in the checked in thing. But no specific goals, but Mark is still around and happy to pick things up. Okay, so that's everyone except myself. So yeah, Rin was born in October, so I was out for a lot. And I did stay more connected even when I was working part-time, which is kind of how I pictured it. I'm looking to do BLE for Zephyr soon. And I was doing I2S in Zephyr, and having a background thread is promising even there, which I'm excited to test. So yeah, Zephyr is still what I'm thinking. And I've been working on and protocol support. And basically I've conceded that like by default we won't have dynamic pin muxing like CircuitPython normally does. When we want to do like full CircuitPython support, we'll have to kind of munge the two together. I3C would be kind of interesting. So yeah, I did more Zephyr work last year. I can't even remember. It's been like so long. But yeah, in December I was doing Zephyr work as well, which is making progress. So that's CircuitPython 2025. What do folks think? Like, how would you characterize what we did in last year for CircuitPython? Like, we released CircuitPython 10. We did a bunch of work on FruitJam. Like, I spent a lot of time doing like USB host reliability stuff to make sure that the FruitJam was ready. I did like the HSTX tuning. So getting that out of the way. CircuitPython 10.1 was some P4 work. Updating the IDF. I also changed the way that SD cards work for FruitJam. So CircuitPython 10 had some renames. Audio effect stuff that the synth folks like have been working on, which has been awesome. Tile palette mapper, I think Foaming Guy did for FruitJam stuff. I did the LV font IO on disk stuff so that you could do emojis by loading characters from a font off the disk, which I was very keen on doing for FruitJam. Pico DVI got better. Oh, I did the garbage collection optimization last year. More IDF updates and SSL stuff. We added CP saves, but only for the FruitJam, because that like impacts like the partition layout. So yeah, last year was very much a FruitJam year. We added the warnings in CircuitPython 9.2.9. for the display changes. Fix the mag tag. Quad color e-paper displays. That's right, I did do some e-paper display work when I was part-time. Yeah, like quad is like white, black, yellow, and red or something. Highlights of this release, 10.0 beta. We already read the full 10 changes, so I'm kind of like... 10.0 alphas were all in June. We got caught up to MicroPython, which is always always a thing. Trying to remember when I took the 8 weeks off. Incompatibility warnings, blah, blah, blah. May. SD card stuff, palette mapper. The garbage collection times things was in May. Number of new audio effects. Thanks to Mark and Cooper. No, Alpha 3. Yeah, I'm so excited for actual threads. I just saw some like background task thing being like, LV font IO was April. On disk font. Yeah, I'm like, I feel like we're gonna get so much more done this year, which I'm excited about. Although I got very, very distracted by this these boards. But they're very cool devices for playing audio for little kids. And they're like just plain ESP32s. Fix button names. Storage remount. Frozen modules. Initial work on a Zephyr port. Yeah. PIO USB. Yeah, so Zephyr came in to this release in March. No, the Discord chat is quiet. Maybe. Let me interact with it. There's a couple. Oh, it's just not scrolled all the way down. There we go. That's better. Thanks, Beata. Okay, so do folks have questions for me? Can I.O. on IMX in January? More audio filters. Man, like all the audio stuff has gotten so much better over the last year. I think that's one of the cooler things coming. Analog devices came out in January. This is probably, oh, this is exactly a year ago, January 9th. Display I/O now supports 24-bit color depth. And then November was the previous release. All right, do people want to talk Zephyr? We did CircuitPython 2025, and I think my 26 is going to be a lot of the same. But definitely, like, in terms of platforms, like the ESP32P4 is going to be, we're going to see that in use more. And that has DSI display support, so I did do that. So CircuitPython has DSI display support. Although I've only tested with like 2 different DSI displays. And Zephyr is definitely like, I want to do Bluetooth because like I want to do Bluetooth one last time and be done with it. And also like be able to test the latest Nordic stuff. So we're like basically 2 generations behind on the Nordic chips. Like our main Nordic chip is still the NRF52840. There's an NRF5340 that's been out for ages. It has twice the RAM, but the CPU speed's about the same. And then they've also announced like a number of different NRF54s that we do want to play around with too. So that's going to happen. One thing that Nerd sniped me yesterday was this post about the baochip, which is like Bunny Wong's kind of next thing. But it's a kind of like more open source system on a chip. Hey, that's nice and big. But it's like a RISC-V core that's clocked at 350 in theory, and then 2 megs of SRAM, 4 megs of ReRAM, which is like taking the place of flash because it's non-volatile. The new Nordic ones have that as well. The new NRF54s, I think, use something along those lines instead. So I saw this yesterday and I got a little bit excited. It's got high-speed USB. It's got these 4 small RISC-V cores that clock at 700 megahertz. I think this is their take on PIO. So it's like it's an actual proper RISC-V core, but I think the idea is that you treat it more like a PIO in the RP2 series. So I kind of expect us to support this at least a little bit. Their goal is to really use this as a platform for security. And that's why they're Rust first in their software development. But I still think it'd be cool. There's now a crowd supply campaign for it that you can sign up for, which is not, oh, it is linked here. So it's like some Pico compatible form factor for this new chip, which could be kind of interesting. But I always like, and this is a theme of the way that I think about CircuitPython, is that it's about, and Adafruit more broadly, is like making things accessible that aren't easily accessible. So things that like are really common in phones or consumer devices, and kind of making those more accessible to people. And these Yotto things are kind of like the reverse of like, these consumer devices are like ESP32s, and we can put CircuitPython on there. Although I gotta figure out how to do this. I think both chip select and the data and command line are on this IO expander, which like we don't have good core support for IO expanders, which is unfortunate. And I'm gonna have to figure out a way around it, because I think it would be really cool for this to work. So when I got back in December, I wanted to jump back into the Zephyr stuff. And the first thing I did was I got it updated to the latest Zephyr version 4.3. because I always like to stay up to date if I can. And the update really wasn't that bad. And I definitely think like I'm gonna put more work into the Zephyr port. I think more Lady Ada is like less convinced that that's the way to go, but I think like with things like chips that have any sort of networking, Wi-Fi, Bluetooth, or mobile, like kind of Zephyr is the way to go for those. The exception being that like all of the ESP stuff, like we're very plugged into the ESP IDF already, so that should be like there's less reason for us to undo that. But so the way that the Zephyr port works is a little bit different from the other ports. There's a couple differences. There's a README here, so here's how to... Zephyr has its own way of managing dependencies. So that's what these are doing for you. And then just like in the other things, we have a makefile, but the makefile doesn't work like the other ports. The way that the build system, and I don't know if I covered this a year ago when I was doing it originally, but the way that the build works is that the makefile calls the Zephyr build, and the Zephyr build builds a CircuitPython library. And instead of using make or cmake to build the CircuitPython library, we actually use async Python scripts to build CircuitPython, which I'm like, I took 6 months off and I went back to it and I still can pick it up. So I'm like quite pleased. Like it's not organized in the best way, but it's also like so much more tractable than like build scripts are because they're asynchronous. I gotta see. Sorry. I'm sure that was super loud. I don't have a big sneeze button. So if there's a board definition, you can do make board equals whatever the board name is. But you can also build any sort of Zephyr board just by using the normal Zephyr way of building something. And it will do its best to take a Zephyr board definition and like make it as CircuitPython-y as it can by default. So I have a stack of boards that I just kind of like wanted to try. And if folks have a bunch of dev boards, you could do this too. But there's this good page for Zephyr supported boards. So if you just like pick one that you have, thank you, Gesundheit. There's some Adafruit stuff here that's supported, and like if we ever wanted to move completely over, we would do that. We would like have to make board definitions for everything. But right now it's like pick a dev board that you have and just see how well like it kind of just works. I've got a couple coming next week that I wanted to test for Bluetooth, but I haven't actually done yet. So like one is called the 612. So you type in there and you can say like, oh, I got this Freedom one. So this is like a Wi-Fi Bluetooth chip from NXP. NXP is like quite involved in Zephyr. So it's got 1.2 megabytes of on-chip SRAM. It's 260 megahertz M33. So like it's gonna be pleasant to use CircuitPython on, and it doesn't like super overlap. So this is one that I'm gonna give a shot at just like bringing up. I did, when I originally did the Zephyr thing, the Zephyr port, I was mashing TinyUSB together with Zephyr. And one of the new things in Zephyr 4.3 was like better USB support in Zephyr. And so I actually did move away from TinyUSB in the Zephyr port because it just makes so much sense to go with the default for Zephyr. Because then if Zephyr, like here, like it's set up for this board, it should just work, right? Like, and you plug into the USB, you'll get the CircuitPy drive and you'll get CDC. I haven't done HID support yet, but like, I think I could do that too. So I also added SPI, I2C, and UART support to the Zephyr port. And so it's not pin dynamic. Instead, what you'll get is, maybe I should just pick a board. Here. Let me plug in. I have an NRF 5340 dev kit here. And let me just use this as an example. So it's got two USB ports. One is like the J-Link and one is the actual device. And I was working on adding I squared S for audio, but I think it's one of the less used parts of Zephyr, and so I'm finding bugs. I'm going to end up having like bug fixing Zephyr, which is just, it's going to be how it's going to be, just like as if I was using some other vendor HAL, like using something in a different way than they expect. It means you're going to find bugs. So I plugged in the NRF 5340, and now I can do CircuitPy. You can see I have test stuff. So I can do TO dev serial by ID Nordic semi. So this is the CircuitPython output. And you can see here, oh, it actually completed. Did it really? It's been crashing, I thought. So now if we go, the cool thing about these dev boards is that you actually do have debug output as well. Is it 2? Yeah, so this is like Printk debugging from Zephyr that we're seeing. And I'm surprised it's not crashing because I thought I still had a bug. So that's kind of cool. I like this way of debugging where we have like, I have a native USB link, but then, oh, there's the crash. Native USB link, but also UART. Oh, and I don't want a new tab. I'll show you how to build it. This up here. You gave it to me and then you didn't give it to me. Over there. Okay, so repos, CircuitPython Zephyr. Source my main repo. Oh, I'm in the Yotto. I'm going to switch to Zephyr Audio Bus IO. My frozen modules are out of date, but that's okay. So I can do make J 32 flash. Oh, and the one thing I wanted to point out with the Zephyr port too is that the structure of the boards directory is a little different. In most ports, it's just boards and then top level, but in boards in Zephyr are 2 levels deep, manufacturer and then the board name. And so we mimic that here. So, and when you do the build, actually I'll show you. Is this interesting to folks? Should I keep talking about Zephyr? Thank you, Yanni. We got about 15 minutes or so left, and I got one question right at the start from DCD. Go for it. Thank you, DCD. So here I'm doing the flash, and all this green output is from the CircuitPython build. I don't think it's on by default, although I'm not sure if I've accidentally committed it. But then there's this debug stuff that's taking parts from Zephyr devicetree and trying to figure out if we should convert it to something in CircuitPython land. I think sometimes it has trouble resetting manually. So now it's updating the firmware. HansLab says, yes, Zephyr is interesting. Programming, verifying, and I'm going to try to catch it before it crashes. So it's come up, and now I'm going to... There's this delay. There's some like buffer that causes it to not go. Who maintains Zephyr for Adafruit boards? Good question. What? Oh. Right now it's the community, the Zephyr community. But in a world where we're actually like releasing Adafruit boards and using a Zephyr port, I think we will. I'm fully expecting to like get more involved in Zephyr for this process. Okay, so let's take a look at, I have this, the left-hand side is not quite right because I have the debug prints getting the serial output as well, but it's not, it's interesting to see that. The underlying print is a little, it works a little different. The way I'm printing the left-hand side is different than how I'm printing the right-hand side, which is interesting. It doesn't really matter. We're just printing more memory than we should here. Okay, so what we can see here is that on board we now have Arduino I2C, Arduino SPI, and these are bus.io, I2C, and SPI devices. So if I print board Arduino I2C, oh, it's a function, but it returns an I2C object, and it will return it repeatedly to you. So this is how we get around so now let me show you another thing. So if I import bus.io, yeah, let's just turn this off. If I import bus.io and I say, oh, I want to make an I2C, and I'm going to do it with board.d5 and board.d6, I'm just picking. It'll say, oh, you can't do that. So I was originally going to have different modules, and then I realized that like when I did SPI, that this was a bad approach because we build on top of bus.io SPI in a number of ways. And so by undoing my decision to have separate modules and just implementing bus.io, like we get all of the display stuff built on top of it working for free. So you can't dynamically construct bus.io, I2C, and bus.io SPI. But if your Zephyr board definition defines pins for a particular I2C or SPI, then you will automatically get boards generated with the names from the device tree. So Arduino I2C and Arduino SPI are the I2C and SPI pins defined for like the Arduino Uno pinout. That is pretty common in Zephyr board definitions. Hamzav says, sweet, I was hoping you folks would embrace an RTOS, and now that Zephyr is what the cool kids are using, it makes sense. Yeah, let me show you. Let me show you how I have I2S working, because I'm like quite excited about it. I just have that crash that I'm seeing. I'm not sure why. It has to do with NRF and blah, blah, blah. But if I open the CircuitPython repo, and it's got to like index everything. And then it has to like, I like Zed, but like, why does it have to index everything? So this is when I was working on I2S out. You can see this. So this is the source files in Zephyr for the I2S. And shared bindings, common how. So Printk is how you like do that, like standard logging and, well, standard printing in Zephyr, and then they have a separate log system. I got it mostly working. I'm just trying to like, I have to do some more buffer stuff too. Like I'm not converting buffers to like the right format for I2S. But this is the exciting part. I now have a thread. So I have a thread that can fill the buffers of the audio. The way it works on other CircuitPython ports is that we have this background tasks system. And if you've ever worked in the core, you see that we have this like run background tasks macro that you call like when you want other things to run. And with Zephyr, we don't need to do that. With Zephyr, we can just create a thread. So to play back audio, we create a thread. And what it does is it says, hey, like get me another. So it uses these, what they call memory slabs, which is like you allocate a range of memory and you have it in like 4 buffers or whatever. And so the memory slab knows like which buffers are free and which ones are in use. And if all 4 of them are in use, basically queued up for I2S output, this kmem slab alloc will just wait. And by waiting, it means that like the thread won't run, other threads can run, like the main CircuitPython one, or USB, or like network. It's nice to have threads. So this is a simple thread for filling the audio buffer where we say, hey, like give me one. Hey, if we're stopping, we'll just give it back and we'll be done. And when you break out of this while loop, you can then join one thread on the other. So CircuitPython uses that during stop. And then we do this fill buffer call, which like does all the math and stuff to figure out, or like fill the buffer based on the audio sample that's playing. And then we write it to I2S, this is the Zephyr call, but it's actually just queuing it up. It's not actually like blocking. It's not a blocking write. It's just queuing it up. So I'm quite excited about this. I just like figuring out like these bugs with NRF. So the bug with NRF is that like the test that I'm doing now is like generate a sample buffer, play it back, stop it, switch like the settings, generate a new sample, play it, stop it, and like do that repeatedly. And the Zephyr driver is just like the Nordic Zephyr driver is trying to free a buffer from the previous run and causing it to crash. So I haven't figured out like why it's trying to free a buffer from the previous run. But I've gotten thoroughly distracted by the Yotto kids toy stuff. So I'm gonna have to, over the weekend, I'm gonna have to chew on how I want to get the IO expander stuff working. But yeah, I'm curious about that too. The other thing I want to show is just like if you have a board that is not listed in that boards directory. So I showed you the 612 that I've ordered. So what you can do here is you copy this little tidbit out, and then you can do a west build. And you can see I've done it for other stuff. And maybe I don't need the NXP part. Oh yeah, and I was trying to get this dialogue chip going. So it's telling me like, hey, last time you ran this, you did it for this dialogue chip or this dialogue board. So you just have to, it just builds in the build directory. It doesn't have the board name in it. And then you can do a test build. And actually, let me clean and clear and test build. So now I can scroll up to the top once it's done. And it doesn't work. Oh yeah, I had some of these problems. Like it does some checking about like setting things multiple times. So I have I'm setting your interrupt driven and serial, and somewhere for the board, somebody decided they'd already turn it on by default, which is annoying. But I actually have already disabled some of that validation, so I might just do that for that check as well. Like, maybe if they were different, but I can just serial and UART interrupt driven. Like, it's complaining that we're setting it twice, but like we have settings that are generic for all the boards. All right, we got about 5 minutes left, and then I think I'll check my email because I've been in the Yotto weeds all day. This is a good thing to end on, even if it takes me more than 5 minutes. So apparently this is the first time I tried to build this board. And so the Zephyr to CP part is the part that's taking the device tree that was kind of computed for the board, and it's trying to figure out settings for CircuitPython. So which modules are we going to build? So like, is there I2C defined? If there is, then we're going to want to build bus IO. If we build bus IO, we want to build display IO. Is there I2S defined? If there's I2S defined, we want to build the I2S support, blah, 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 and all the synth stuff. So it's taking drivers and it's trying to find it. It's looking for, it didn't find any flash devices. So like, this is like, okay, where are we going to put CircuitPython with a CircuitPy drive? And then also like, where is what RAM can we use for the CircuitPython heaps, or the heap for CircuitPython. So that's what this process is doing, and then this is the like determining what we're going to enable. So like, oh, we found bus IO SPI. Here's other things that we don't support, blah, blah, blah. And then it found this, it's failing because it couldn't find this NXP lct-pmod. So this is how Zephyr does pinouts for boards, so that you can like plug a feather in or something and have kind of like, they call it a GPIO nexus, but it's how you have like a standard pinout for something. And I'm using those in this device tree to CircuitPython board conversion thing to generate board dot something for different pins. And so this is telling me that I don't have one for lct-pmod. So let's actually just add it. So the build stuff is in cptools because tools is installed by Zephyr. Zephyr installs stuff there. But if we go to Zephyr to CP, we'll see that we have connectors. And there's LCD, there's CAM, and I'll just add a new one here. lct-pmod. And I'm in Z, so it's giving me its best guess that is not helpful. I wonder, they should have like a toggle for that. I doubt that the pinout is actually right. So what I'm going to do is I'm just going to look in Zephyr and search for it. And it should be able to find it. It doesn't have single quotes, it has double quotes. And look, I picked the one board that's got it. Yay! But this page here, this YAML will tell me what the pin numbers are. So let's do LCDWR. This. So now I'm just going to list them in order. Touch, SCL, CD, DC. I could try to copy and paste in to get my AI-powered suggestions to be useful, but I'm not going to do that. because it's not that many. Touch reset and LCD CS and touch interrupt. Okay, which is the 8 pins. PMODs are 8 pins, I think. So now, if we go back to our build, we should be able to build now. I wish I had the board. Next week we can load it on the board and see how far we get. It should boot up and you should get USB, no CircuitPy drive, but you should be able to get CDC and then it'll like be in safe mode because there's no CircuitPy drive. What we can actually look at is take a brief peek and figure out how we could set up the CircuitPy drive. So this script is working off of the generated device tree, which you can find in the build system if you go build Zephyr DTS. You mentioned Zed a few times. When you were streaming last year, you had a different editor. What changed? I used to use Sublime text, and the thing that changed was, although in that case the AI-powered suggestions were annoying, there are sometimes they're really helpful. I don't find that it's that common right now, but one example is I usually do a lot of debug prints, and if I'm going through deleting the debug prints, it usually can catch on and like make it easier to jump and do that. I used windsurf for a little while, and it was quite good at that. And then windsurf, like half the team went to Google and they got bought and all that stuff happened. So I stopped using windsurf, and Zed is open source, but by a company. And so I like kind of want to put my eggs in that basket. They do have like Cloud Code integration, but I still prefer just the command line Cloud Code. So yeah, like just the AI powered like editing completion is something that I do find useful. Although I may be moving away from that into more just like straight up Cloud Code. But let's take a look at this. So it's saying like, oh, Zephyr Flash is this device. And here's a link to the Flash controller, and then there's a code partition. So it seems to me like, hi RSBone. It seems to me like the code might be stored off the device, which I'm actually surprised by. You can see flex by, and then there's these fixed partitions. And storage partition is used by, I think this is base address and length. There's 2 images. Let's just take a look. Do we have, what does it say here? Does this not have internal flash? I guess, yeah, it includes just SRAM. On-the-fly decryption engine securely access off-chip execute and place flash. Interesting. So the way that we can get CircuitPy working here, yeah, that doesn't have flash. It's like the same blurb. So usually the reason you don't have flash is because it's like takes up a lot of chip space. Oh, it's high-speed USB. I'm not entirely sure how well it works sharing flash, but okay, so if we find the source of that, so now I'm in Zephyr and I'm looking at the source device trees. The one that I was looking at earlier is like the one that's been merged all together for the build. These are like the individual pieces. And you can see that like it has an Arduino header, so we're going to get all of those board names by default, which is cool. And so here's our external flash. Size must be 64 megabytes times 8. And then we can see here that the storage partition is 58 megabytes minus 128K. So it's 128K here for the bootloader, 3 megs for each of the firmwares, and then the storage partition is kind of the remainder. So what we can do is we can actually create an overlay that deletes the storage partition and makes a CircuitPy partition instead. I didn't want to reuse the storage partition because there might be Zephyr code that uses a storage partition if it's available. So the way to fix this would be to add a device tree overlay that deletes the storage partition and then adds it, but maybe smaller so that like CircuitPython could have some space as well. Let me just do that because I know I ordered this board. I'm going to get it next week and I might as well do this little piece. So it's not simple, but it's also something I've done before already. So this boards directory is like not strictly for CircuitPython. There's all these overlays. And let's just take a look at like this one. So if we duplicate this, but we're doing it for the, what is it called? The Freedom RW612. So this is probably, this is one of those things that's good to document. RW612. RW612. So this is going to delete all the partitions, which I don't think we want to do. We could delete all the partitions if it was just a storage partition. But this is actually storing our code as well, so we don't want to do that. So we're going to do this. We're going to copy that and put it here and make sure it's the same, which it's not. And then we're going to do partitions. Yep, and I want to delete that. And I want to delete storage partition. I wonder if I could just override the size. And then I'm going to make a CircuitPy partition, which I have done. Yeah, see here, I'm doing it for the IMX 11 series, 1100 series. And it's going to be partition at 6200. I basically want to copy this. But I could actually add a storage partition, but I probably doesn't need it. So I think I'll just do this. Copy storage, but then I will rename it. CircuitPy and CircuitPy. Now this is a little tricky because it's going to look like it doesn't work, but the way that if you explicitly create a CircuitPy partition, like the C code does something different, so it doesn't matter that the Python build can't find a flash for it. Although maybe it's smart enough to at least tell you that. Anyway, I don't actually have this board, and it's not compiling because I needed to set a host name. It's a Wi-Fi board, so yeah. So that's how it goes. That's how it goes if we're actually, you know what? Sorry, I was about to. But the other Wi-Fi board that I have here is this one, and it doesn't have a host name. So I'm not sure exactly why it's crashing. It wants to have net host name set. I know I'm over time. It's not a hard stop. But that gives you some idea about Zephyr board bring up. It's not always smooth, but yeah, it's still better than like starting from scratch. So, all right. No final questions. Let me switch back to the camera. Thank you everybody for joining me on my first deep dive in a while. Happy 2026. I plan on doing this every week for an hour, like I said. If you have questions, I'm happy to answer them. And if it takes me longer to answer them, that's great too. Think about CircuitPython 2026. Anything that's on your radar that's not been. One thing I didn't talk about directly was that I think there is going to be a role for like LLM generated CircuitPython code, and we should think about how to best support people who are doing that. So that's definitely going to be a part of my post. Yeah, thanks all. If you want to support me, you can go to adafruit.com, purchase hardware there. You can also purchase through resellers if that's more convenient for you. With that, thanks all, and I'll probably see you next week. Since I said probably, I remembered that if you want to join the Discord, go to adafru.it/discord. And if you want me to let you know whether it's going to happen or not, or maybe Tim's going to fill in, there's a deep divers role. You can ping me on Discord at Tannewt, and I'll add you to it so that I can let you know what the status of everything is on there. Thank you all. I'll see you on the Discords. Have a great weekend, and see you next week. And the window. Actually do the window. Not too bad. Wow.